So this is the history of temperature on our planet going back 100 million years. And I don't have any tattoos. If I got a tattoo, this is the tattoo I would get. This is sort of like a orienting document for me that I wish everybody could know and feel and see. It's central to the Probable Futures platform. What you see here is time on the bottom and 4 panels. 1850 to 2100 is at one scale. So this is the individual years are visible here. Here, it's a longer period. Here now, time has gotten stretched out even more. So it goes from 10,000 to a million. And here it goes from a million to 100 million. So it is not a consistent time scale. This is zooming out, zooming in somewhat, zooming in more, zooming in a lot. And this is the period here in the green of civilization. This is when we settled. And 0 in this case is the average temperature between 1850 and 1900. So the average temperature before industrialization, before we really started changing the atmosphere with fossil fuels. And what you see is that 0 is quite consistent going back 12,000 years with small variations around it. Before that, our first ancestors came in around here and they experienced wildly shifting climates. So this is the deepest, this is called the glacial maximum, what is sort of colloquially known as a deep ice age. And these warm periods relatively are called interglacials. We live in an interglacial, which means there are still some glaciers on Earth. There's still some ice cover and not maximum ice cover. So we had this pattern. We've got the yellow band. This is a long period of time when temperature went up and down as changes in the Earth's tilt, its axis, its orbit, made the Earth change its orientation towards the sun so that it would either cool gradually or actually warm pretty quickly. And now we've been in this long period where it was stable. And when people say, well, what's so big about 1 degree? Well, 1 degree is breaking out of this green band. And 1.5 is near the maximum of human experience. But also, if you get out around 2, 2.5, you're outside the bands of this stable trough, this stable pattern. And so what happens outside of that? Well, we have a nice map of it, which is there's nothing inherently stable about any of this time, but also this whole period of time is very warm to our liking, much warmer than we would like. So if you go back 70 to 100 million years ago, this is the age of dinosaurs. I, like many other kids, thought dinosaurs were pretty cool when I was a kid. A question I never asked is, why were there no humans around when there were dinosaurs around? The answer was, it was just too hot for big mammals. Dinosaurs are giant lizards. They're not quite exactly lizards, or they weren't exactly lizards, but they are mostly cold-blooded. And cold-blooded creatures, lizards, snakes, creatures that benefited from heat, they thrived. We could not have lived on this Earth anywhere. It was just too hot for us physically. And so this is our climate. This is the climate we can thrive in. There's a reason we evolved and there's a reason we were so successful as a species, but this is the ideal band for us. This is the band of temperatures in which we really thrived. That's the biggest discovery for me that I wish were more publicly known, which is that the Earth's climate was unstable until 10,000 years ago, at which point it stabilized in this period scientists call the Holocene. But basically starting 10,000 BCE, so 12,000 years ago, starting 10,000 BCE, the climate stabilized at this level that was just perfect for humans. Nowhere on Earth was too hot for us. So we're both big mammals. We need to offload heat. If we are in an environment that is 95 degrees Fahrenheit or 35 degrees centigrade and 100% humidity, you and I would die very shortly in that environment because we could not cool. We would overheat. That's the ceiling on human habitability. And from 10,000 BCE to now, it was never that temperature. It was just below at the hottest places. So the hottest places you've been, you're in Atlanta on the worst summer day, you're still well clear of that, well short of that level. If you're in the shade, you have a drink, you're hydrated, you're okay if you're healthy. And so there was this stability over 10,000 years. And I realized that stability makes everything else easier. That stability is probably the handmaiden to complexity, to this civilization we have that's so robust. This is the framework that I think people can benefit from understanding is we lived in a very narrow period of time that had basically no climate change. And so when we talk about climate change, it is new for humans since the dawn of civilization. And it was so long that we stopped paying much attention to it. And I actually was meeting with a climate scientist named Ken Caldera at Stanford at the time. And I asked him, I said, it seems to me like civilization started. Settlements, the first settlements are around 9,500 BC, that civilization is built because we have a stable climate. And he said, yeah, everybody knows that. And I was like, nobody knows that.